In this session, we will do like a deep dive into the data engineering part in or workload in Microsoft Fabric. So we will cover data engineering capabilities, including the Lakehouse, Spark, notebooks. So I'm glad that you are joining the session. Also to learn about some updates about the product. So I'm a business intelligence engineer, so I have a newsletter which is mixing humor of things that challenges me during my daily routine. So, and I try to help entities, not only entities, but anyone seeking for help to make better decision in different business processes, of course, based on data. That's the fuel. So my LinkedIn newsletter is called the BI Chronicle, and my AKA is the Data Witch. So let's start by we are going to meet Alex, starting with his life routine, who is a data engineer at Retail Hub. It's a growing e-commerce company which is facing, let's say, significant challenges with their data. So data is spread across various systems: POS, online transaction, inventories, customer services. So Alex's daily routine is involved like juggling, let's say, multiple tools and platforms, each with its own set of complexities. So we can cite like we can mention the manual integration of data from different sources, which is considered as time consuming and prone to errors. So different departments at Retail Hub use their own systems. So we are talking about a scenario leading to data silos that make it difficult to get like a holistic view of the business. And as data volumes like grew, the existing infrastructure, from the point of view of Alex, struggled like to keep up. So he spent significant time troubleshooting performance issues, trying to optimize like slow running queries, and which at the final, like at the end, detracted from more strategic work. So during a technology conference, Alex attended a session on Microsoft Fabric. So it's an end-to-end analytic platform, promised to solve many of the challenges he faced. So Alex is you, it's me, is everyone trying to understand what Microsoft Fabric about. So data engineering in Fabric enables users. So we are going to just, like you see, focus on the data engineering part. So enables users to design, build, and maintain infrastructures and systems that enable organization to collect, store, process, and analyze large volumes of data. So with MS Fabric, you can create and manage your data using Lakehouse, design pipelines to copy data in your Lakehouse, use Spark job definitions to submit, for example, batch streaming job to Spark clusters, and even use like notebooks to write code for data ingestion, preparation, and transformation. So the journey of Alex with data engineering part in MS Fabric, starting with building the Lakehouse architecture of the Retail Hub. How to maximize the data potential. In this case, with Data Lakehouse, that's the first part. And when entering into the engineering world within Microsoft Fabric. So Microsoft Fabric Lakehouse is a data architecture platform of course, for storing, managing, and analyzing structured and unstructured data in a single location. So it's flexible, scalable, and allows organizations to handle large volumes of data using uh, various frameworks to process or analyze that data. So, and it's possible to integrate it with other data management and analytic tools, of course, to provide, let's say, more comprehensive solution for data engineering and analytics. So as you can see in the screenshot, it's something you get used to maybe when working with Power BI online or Power BI desktop. Moving to the Lakehouse SQL analytic points. So the Lakehouse creates a serving layer by automatically generate a SQL analytics endpoint and a default semantic model during creation. Um, this, in my opinion, like this new see-through functionality will allow users to work directly on top of the delta tables in the Lakehouse and to provide like frictionless and performant experience all the way from data ingestion to reporting. It's important also to note that the SQL analytics endpoints is a read-only experience and doesn't support the full T-SQL surface area of transactional data warehouse. So if I explain better, only the tables in Delta format are available in the SQL Analytics endpoint. Parquet, CSV, and other formats can not be queried using the SQL Analytic points. So if you don't see your table, you will need to convert it to Delta format. Of course, you can set object level security to access data using SQL Analytics endpoints. Security rules will apply for accessing data via the SQL Analytics points to ensure, of course, data is not accessible in other ways. It's recommended to use workspace roles and permissions. Another point related to SQL analytic endpoints is like the automatic discovery, table discovery and registration. This feature provides a fully managed file to table experience for data engineers, and not only engineers, data science also. You can drop just a file into the managed area of the Lakehouse, and it registered into the metastore with the necessary metadata, such as, for example, column names, compression, formats, etc. Currently, the only supported format is Delta table. So let's hope in the future we have more features, an improvement for this component. As I was talking about the automatic table discovery, there is another Fabric Lakehouse can automatically discover all the data sets already present in your data lake and expose them as tables in the Lakehouse and, of course, warehouses. There is always a single condition. As I always said, the tables must be stored in the Delta Lake format. Uh, about multitasking with Lakehouse, this experience provides a browser tab design that can allow you to open and switch between multiple items seamlessly, allowing you to manage, for example, your data Lakehouse and in or more efficiently than ever. So you don't need to juggle between different windows to make your data tasks. So um, that's the way that it is more efficient and user-friendly as possible. The smooth interaction. You can upload or run data load operation in one tab and check on another task in different tabs. So with enhanced multitask, the running operations are not cancelled when you navigate between tabs. So you can focus on your work without interruptions. Of course, selected objects, data tables, or files remain open and readily available when you switch between tabs. The context of your data lakehouse is always at your fingertips. There's also behind a non-blocking reload mechanism of your files and table lists, so you can keep working while the list refreshes in the background. So you have always the latest data while providing you like with a smooth and uninterrupted experience. Moving to how to get data in the Lakehouse. So Lakehouse currently supports over than 100 data sources. You can connect to a wide range of data sources. This include, of course, traditional databases, cloud storage solutions, SAS applications, and more. Of course, this extensive connectivity makes sure that you can gather data from virtually any source your organization uses and provide you with a unified data platform. Also, we have the direct upload of files from the computer. So the process is very simple. How to get data from your file on your computer, and you can upload them directly to Fabric. It's useful for quickly ingesting CSVs, Excel spreadsheets, JSON, and other common data formats without needing to set up a complex data pipeline. So just you can simply drag and drop the file into the platform, and that's it. Applying transformations using data flows. So once your data is there in the Lakehouse, with Microsoft Fabric, you can have tools to transform and prepare your data, which is like the data flows. You define data transformation steps. It's something many similar to people who worked already or have knowledge about active Azure Data Factory. So you can do data transformation like filtering, joining, aggregating, or even further complex processing operations. And the data flows support both no code and low code options. So making it accessible for both technical and non-technical users. We have also the copy activity, especially when dealing with large-scale data. Microsoft Fabric supports the copying of entire data lakes up to, we can say, petabyte scale. So it's very important for organizations that need to replicate, move, or backup very or big amounts of data across different environments or cloud regions. So the copy activity is designed to be highly efficient and scalable, especially with very large data sets which need to be transferred without performance bottlenecks. For Spark lovers, of course, for more advanced data manipulation and processing, today Microsoft Fabric supports the use of Fabric code. These allow data engineers and scientists to write custom code in languages like Python or Scala. And through Spark, users can connect to various data sources, perform complex transformations, of course, and execute, let's say, distributed like computation across like large data sets. Another thing is like the shortcuts. The shortcuts in Microsoft OneLake allow you to unify your data across like domains, clouds, and accounts by just creating a single virtual data lake for your entire enterprise. So all Fabric, let's say, experiences and analytical engines can directly connect to your existing data source. For example, Azure, AWS, OneLake, through a unified namespace. So OneLake manages all permissions and credentials, uh, and you don't need to separately configure each Fabric workload to connect to each data source. And you can use, of course, shortcuts to eliminate edge copies of data and reduce process latency associated with the data copies and staging. Of course, as I mentioned about like the Delta Lake tables, today the Lakehouse provides this feature to load common files types to an optimized like Delta table. So today the supported files are Parquet and CSV. The file extension case doesn't matter. Also, with the single file load, users can load a single file of their choice in one of the supported format by selecting directly load to data table in the context of the menu action. We have also the folder level load, so you can load all files under a folder and its subfolders also at once by selecting load to delta table. Just like this feature automatically traverses all the files and load them to a delta table. Just we need to make sure that only files of the same type can be loaded at the same time in a table. We can also choose to load files and folders to new tables or an existing table. So, and of course, for CSV file, users are allowed to specify if their source file, like for example, includes headers to be used as column names. So you can see that these details are somehow very similar to Power Query if you import, like for example, a CSV file to Power Desktop. So, and of course, tables are always loaded using the Delta Lakes table format with V-order optimization enabled. Delta Lake, so what is the V-order? And before that, what is the Delta Lake optimization? Let's start with defining the V-order. It's a write time optimization to the Parquet file format to enable lightning fast reads under the Microsoft Fabric compute engines, such as such as Power BI, SQL, Spark, and others. So Power BI and SQL engines make use of the Microsoft Vertiscan technology and the V-ordered Parquet files to achieve in-memory data access time. So this is for the case for Power BI and SQL engines. Spark and other, let's say, non-Vertiscan compute engines also benefit from the V-ordered files. Let's say I think with an average of 10% faster read times, with some scenarios up to, I think, 50%. V-orders works by applying like special sorting, row group distribution, dictionary encoding, and compression on Parquet files. This requires less network disk, CPU resources, of course, in the compute engines. So to read, and of course, it provides cost efficiency and performance. The order sorting has 15% impact on average write times, and it provides up to 15% more compression. So it's 100% open source Parquet format compliant. All Parquet engines can read it as a regular Parquet file, and that's what makes like the delta tables more efficient than ever. So it's applied in the order is applied at the Parquet file level, delta tables, and its features such as, for example, z order, compaction, vacuum, time travel, etc., let's say, are orthogonal to v order, and they are compatible and can be used together for extra benefits. For the new features, like try to, as I do it each month, I try to check the new features. We have like today it's the previous the lake schema feature, which introduces data pipeline support for reading the schema from Lakehouse. We have also the support for Git integration and deployment pipeline. The Microsoft 365 connector now supports ingesting data in Lakehouse. For the second and the third, they are still in preview, so be careful, guys, and feel free to upscale any bugs on the platform. Going to Apache for Apache lovers in Microsoft Fabric. So if we are going to start with Apache, we need to talk about the Apache runtime within Microsoft Fabric, which is Azure integrated platform based on Apache Spark, and enables the executions and the management of data engineering and also data science experiences. So it combines like the components from both internal and open source sources to provide a comprehensive solution. So the major component of Fabric runtime, we have the Apache Spark. It's open source distributed like computing library to enable large scale data processing. We have the Delta Lake, which is also open source storage layer that brings ACID transactions and other data reliability features to Apache Spark. And we have the default level packages for Java, Scala, Python, and R. So these packages support diverse programming languages, and they are automatically installed and configured, allowing developers to apply their preferred programming languages. So this is by default, all new workspaces use the latest runtime version, which is currently 1.2. And this runtime is built upon a robust open source operating system to ensure like the compatibility with various hardware configurations and of course system requirements. Moving to the next component, which is Apache Spark Compute. As I said, like this platform is designed to deliver unparalleled speed and efficiency. So with, let's say, starter pools, you can expect rapid Apache like Spark sessions to initialize. It's typically between 5 to 10 seconds. So you don't need any manual setup. You can also get the flexibility to customize the Apache Spark pools according to the specific requirements. So the platform somehow enables you to optimize the analytic experience. Moving to another component which is important in Spark and Apache Spark runtime is the Spark pool, which is like a way to tell Spark what kind of resource you need for your data analysis. So you can give it a name, choose how many and how large the nodes, when I say the nodes, like the machines that do the work are. So you can also tell Spark how to adjust the number of the nodes depending on how much work you have. Creating, of course, the Spark pool is free. You only pay when you run a Spark job on the pool, and the Spark sets up the nodes for you. So if you don't use Spark pool for 2 minutes after your session expires, your Spark pool will be deallocated. So this default session expiration time period is set up to 20 minutes, and you can, of course, change it if you want. If you are workspace admin, you can also create custom Spark pools for your workspace and make them the default option for the other users. So in this way, you can always save time and avoid setting up new Spark pools every time you run a notebook or a Spark job. One other detail to mention is like the custom Spark pools take always about 3 minutes to start because Spark must get the nodes from Azure. Moving to the nodes. So as I said, an Apache Spark pool in an instance consists of one head node and worker nodes. So could start a minimum of one node in Spark instance. The head node always runs extra management services such as Livy, Yarn services, Yarn Resource Manager, Zookeeper, and Apache Spark driver. So all the nodes run services such as Node Agent, Yarn Node Manager, and all worker nodes run the Apache Spark Executor services. The node sizes, as you can see, can be defined. Of course, the Spark pool can be defined with node sizes that range from a small compute with 4 vCore and 28 gigabyte of memory to double extra large compute nodes, as you can see. And they can be altered after pool creation, although the active session should be restarted. We can talk about also the auto scale, since the pools allow automatic auto scale, or this automatic scale up and down, of course, of compute resources based on the amount of the activity. So when you enable the auto scale, you set like the minimum and the maximum number of nodes to scale. And of course, there is the dynamic allocation principle, which allow the Apache Spark application to request more executors if the task exceeds, let's say, the load that current executors can bear. So, and when you enable the dynamic allocation option for every Spark application submitted, the system reserves executors during the job submission step on the minimum nodes. You can specify maximum nodes to support, of course, successful automatic scenarios. Moving to the Apache Spark job definition, which is a Microsoft Fabric code item that allows us to submit batch streaming jobs to Spark clusters. So by uploading the binary files from the compilation output, for example, jar files, from Java. You can apply different transformation logic to the data hosted on the Lakehouse. So to run that job definition, you must have at least one Lakehouse associated with it. There are a few ways you can get started with the creation process. You can go to the data engineering homepage directly, so you can easily create Spark definition through the Spark definition card under the new section, or you can you can create it through the create page under the data engineering on the left side. Or of course, you can of course through the workspace in data engineering, so you can always go back to the data engineering if you get lost. Another component in Apache Spark that you can find in Microsoft Fabric is the libraries, and we have like two types of libraries, so the built-in and the public. Actually, three types: built-in, public, and customs. The built-in libraries, each Fabric, like Spark runtime, provides a rich set of popular pre-installed libraries. You can find them all in the documentation. We have also the Fabric libraries, and they are sourced from repositories like Conda, which is currently supported. And we have custom libraries that refer to code that you or your organizations build. So we need to make sure that they are in the format of jar, tar, gz, whl. So because Fabric supports .tar.gz only for the R language. For Python, for example, it uses like the .whl format. As best practices is always the default setup, default like libraries for the workspace. The admin, of course, is responsible of that, and by creating a new environment, installing all the required libraries, and attaching this environment to the workspace. Or the second scenario is like to persist the library specification. If you want that to persist, you need to install libraries in an environment and attach it in the code items. In my opinion, one benefit from this approach is that it saves effort of running the code that requires common libraries all the time. So you have the libraries, you can work in all Spark sessions if the environment is attached. And the third scenario is to align the installation. So if you're interested in the one-time use within an interactive, let's say a runbook, a notebook of a library that isn't installed, so you may need to use the inline installation with the commands, the inline commands. You have like they allow you, like the command, they allow you to have the library in the current notebook sessions, and they don't and the library doesn't persist across different sessions. As I already talked about environments previously, so Microsoft Fabric environments is a consolidated item for all your hardware and software. You can select an environment, different Spark runtimes. You can configure your compute resources, install libraries from public repositories. There are multiple entries of creating new environments, standard, or you can create during selection. So three major components in the environment, which are like the Spark compute, that includes like the runtime, the libraries, and the resource. Of course, the environment can be attached to your data engineering or data science workspaces, or your notebooks, and Spark job definitions. The new features for last period at least, there is a runtime. I said that the 1.2 is the default, but the Fabric runtime 1.3 remains and still preview, so it includes the incorporation of Delta Lake 3.1 compatibility with Python 3.1. So other it also supports like start pools and integrating with environment and other library management capabilities. And of course, we have the native execution engine for Apache Spark is now on preview, but only for the Fabric runtime 1.2. Moving to the notebooks, for notebooks, of course, lovers, it's the same principle. It's a primary code item to develop your Spark or Apache Spark jobs. And with the Fabric notebook, you can get started with a zero setup effort. You can easily explore and process data with low code experience, analyze data across raw formats. So let's say CSV, text, JSON, etc., and even processed file formats like Parquet, Delta Lake, and of course to be more and more productive with enhanced authoring capabilities and built-in data visualization. You can, of course, export notebook to other standard formats into the standard notebook file, which are used to Jupyter-like notebooks, even HTML that can be opened from a browser directly, a Python file, and even a LaTeX file.
Amira, a gentle reminder that it's time to maybe wrap. Yeah.
How much time do I have?
We've only passed 2 minutes over, but you can have another couple of minutes. Yeah.
Okay, thank you for your understanding. So you can explore like the Lakehouse note data with an existing notebook, or you can create a new one. It's easy and in the same workspace and the current Lakehouse, you can have all the notebooks. Of course, you can source control the notebooks and using Git integration for source control with Azure DevOps. So when you just commit the notebook item to the Git repo, the notebook code is converted to a source code format instead of what we call standard IPYNB file. What's new for the notebooks are the deployment pipelines to deploy your notebook code across like different environments like test, dev, production. It's still on preview, but it will enable you to streamline your development process. It's like you can see it's similar to the Power BI deployment pipeline. We have also the APIs, the public APIs, to mainly for management, to automate like the pipelines and establish CI/CD. So those pipelines make your life easy to manage and manipulate the Fabric notebook items and integrate like notebooks with other tools and systems. We have also the schedule, public APIs to schedule, and it's more oriented to schedule the running items with the specific requirements. Going finally to the data pipelines in Microsoft, that's the last part of our data engineering journey. the data pipelines, you already heard about this. It's a series of steps to collect, transform data from its raw format. You can use it for analysis and decision making. So the first component is activities, where you can define actions to perform on your data. For example, you can use copy activity to copy data from SQL Server to Azure Blob. Then you can use a data flow activity or notebook activity if you want to process complex transformation. We have like three types of activities: data movement activities, data transformation activities, and control activities. That's it, the journey, our journey with the data engineering in Microsoft Fabric. That was the journey of Alex. Remember also that Alex is you and me and everyone, sorry, to interested with the Microsoft Fabric, and of course the